On we go with our polynomials, but we're going to be doing something different with them. We will be factoring polynomials. So just real quick, this is like an overview of factoring. Okay, you probably did something like this in earlier grades. You did a factor tree. You factored a number, and you just divided out what you could until everything was prime. And you might have rearranged your answer because the numbers went from least to greatest, but essentially you ended up with a multiplication problem that if you multiplied would bring you back to the original number. Well, now we will be factoring polynomials. So our answer is going to look like a multiplication problem, just like it did up here. So for instance, and I'll get to the process in a second, this is just what are we actually doing. So we'll start with a polynomial, and our answers are going to look like this. They're going to look like the problems in the one assignment we've already done called multiplying a monomial times a polynomial. Remember you distributed 7x times x squared. See, 7x to the third. 7x times 2x, 14x squared. 7x times 5, 35x. So we've already done multiplication where we went from here to here. Well, now we're going to go backwards and factor and go from here to here. It's like a circle. Okay, so let's get this started, and we're not going to do all of these. These notes are very long. So this up here is just practicing. We're going to be factoring out something called the GCF, or the greatest common factor. Well, how do you find it? Now, these are not polynomials. You can see they have this symbol. It's just, we're going to practice just a couple of these. How do you identify the greatest common factor? If you're going to factor it out, you have to know what it is. So we'll first start with looking at the coefficients. Okay, so you look, 3 and 9. Well, what's the biggest number that goes into 3 and 9? And it's a 3. Okay, 9 is too big. 9 doesn't go into 3 evenly. So it's a 3. Now you look, this has an x, this has a y, but neither one are common between both terms. So that's what the C is stand for. So only 3 can go into those two terms. 3 is the greatest common factor. Okay, what about this one? What do you think? Well, you try to answer that one. And probably thinking, well, 4, definitely, but see, that's a y, that's a z. So it's only a 4. Now this is going to change. Sometimes it'll be just a number. Sometimes it might be a number and a variable. So let's look at the numbers first. 12 and 2. 2 is the biggest number that goes into 12 and 2. Now we have an h and an h squared. So which one do you use? We will always use the smaller exponent. I'm writing this off to the side here. So we have an exponent of 1, exponent of 2. We use the smaller exponent. We don't use h squared because h squared cannot go into h. It's too big. Okay, so you can see there are a few more. I just want to show you 4 because there's no coefficient here. So if there's no number there, you don't write anything. You kind of move on to the variables. You see there's an x and an x, so that would be just an x. Okay? So we'll do a couple more. Then down here, I'll actually show you how to factor, do the problem. So looking at this one, we have a 4 and a 16. And you have to kind of look at the problem about 3 times. We have an a to the 4th and an a squared. So they both have an a. And I choose the smaller exponent. This has a b, that has a b. This is a 5, that's a 7. B to the 5th. If you want to try those, I'm not going to answer them. You can submit those answers to me, and I'll check them for you. But I don't want this video to be 20 minutes long, and you don't either. So now these are the actual practice problems. So the first thing you will do is, I'll write it over here, and I'll move it so you can see it. You have to identify the GCF, just like we did above. So if you look at number, we're going to skip 10 actually, because they're like terms, and we'll just bypass that one. So let's look at 11. 18 and 36. So you might be thinking, hey, 6 goes into both of them. Right, it does. What's the biggest number? And you might think 9. Keep going. Higher. It's actually 18. So I kind of write that off to the side. Now look, this has an h, that one doesn't. So it's just 18. Now draw parentheses, and I put my subtraction sign in. Well, how do I fill in? That's a crooked subtraction sign, sorry. How do I fill in here? Well, think about it. When we used to multiply, we would multiply and subtract exponents. Well, this is the opposite. So I'm going to divide these two terms by the GCF. Let's see, these 18s cancel out. I get an h. 36 divided by 18 is 2. So that's it. Let's see if we're right. If I multiply this, I should get my original problem back. 18 times h, 18h. 18 times 2, 36. So we'll try a couple more, and that's really what we have to do. Identify the GCF to divide. However many times is however many terms in your problem. So here we go. Look at the coefficients, 10, 15, and 20. I'll write down a 5. Now I look, they all have a G. So I'm definitely going to use that. Now I pick the smallest exponent, which is G to the first. I draw a parentheses big enough to fit 3 terms in. See how my signs are addition? Okay, big moment. Divide everything by the greatest common factor, 5G. And 10 divided by 5 is 2. Now I'm just subtracting exponents here. G to the third and G to the first is G squared. 15 divided by 5 is 3. G squared divided by G to the first, subtract exponents, is G to the first. 20 divided by 5 is 4, and those G's cancel. That's our answer. Let's test it. 5 times 2, 10. G times G squared, G to the third. Distribute 15, G squared, there it is. Multiplying the last one, 20G, there it is. Okay, so we're at 7 minutes. So let's just pick a couple to try. Maybe we can do 14 and 15 and 17. We'll do those 3. Okay, so for 14, again, you can always pause and try whenever you want. 15 and 20, that's a 5. That has a y, that has a y. Smallest exponent's a 2. Now this has a z, but that one doesn't. So I do not write down z. Remember, it must be a common factor. Okay, so divide by your GCF. 5y squared. 5y squared. 15 divided by 5 is 3. Y to the third, y squared, subtract exponents, y to the first. Now that has a z, this doesn't. I have to have it in my answer right there. 20 divided by 5 is 4. The y squareds cancel. And I stop right there. It's a distributive problem. Okay, number 9. Or no, sorry, I was looking at that 9. Number 15, 9, 6, and 12. That would be a 3. X, X. Well, that one doesn't have it. Oh, this has a z. That doesn't have a z. This has a y. That doesn't. So it's only a 3. They do not have a common variable all the way across the problem. So that's actually going to make things much simpler for us. Divide by 3, divide by 3, divide by 3. So I'm just dividing the coefficients. The variables stay the same because there's nothing affecting them. All right, and last one. Pretty big problem. I chose a little challenge for us here. So 10, 20, and 15, you realize that's a 5. Again, I write this off to the left because I'm going to have parentheses here. X, X squared, and X. X to the first power is the smallest exponent. Y squared, Y, and Y. First power again, Z, Z, Z squared, so they all have it. First power is the smallest. So this is going to be interesting. Here we go. Divide by 5xyz. And some of the division easier than others. That's pretty typical in math. So 10 divided by 5 is 2. The x's cancel out. The z's cancel out. I just have y to the first power. Coefficients give me a 4. The y's cancel, the z's cancel, but I do have x to the first. I have a feeling something similar will happen here. 15 divided by 5 is 3. X's cancel, y's cancel, because they have the same exponent. Z subtract. We're done. Again, you can try any of these and then let me know what you got. We'll check it. The assignment is going to look very similar, same font. Has this 8.2.3 up here. There are 15 of them. Do your best. If you need help, let me know.